In this first problem, we have an absorption tower. So here's my absorption tower. And we are going to, in this tower, be bringing in an ammonia and air mixture to the base of the absorber. So it's going to come in at the bottom part of the tower. Okay. Air plus ammonia as a mixture. Now in this tower, we're going to recover 99% of the ammonia that's in this air plus ammonia stream. The content in the air that's fed is 20 mole percent ammonia, and perhaps you may be able to do in your head 80% air. The flow rate of this stream is 300 pound-mole per hour. Now clean air is going to exit this. Now it's not going to be 100% clean. In fact, we don't know what the content of this is going to be, but we know it's cleaned air with cleaned in quote. So it's going to be mostly air with some ammonia, and the content is somehow described by this cryptic statement: we're going to recover 99% of the ammonia. Reading on, it says pure liquid water will enter the top of the absorber. So in the top, we're going to bring in water, and it's 100% water. And this water is going to come in through the absorber. It's going to intermingle with this air and ammonia and pick up some of the ammonia from the air and then exit. And let me... So this is going to be water plus ammonia. Now again, we do not know exactly how much is going to be, but it will be water with some ammonia that has been picked up inside the tower. So if we use this now to fill out the material table, we have 4 streams. I'll label them stream 1, stream 2, stream 3, and stream 4. These values that are given to me are in mole percent, and my total flow is going to be in pound moles per hour. So for stream 1, what I know is it's not going to contain any air or ammonia, but it's pure water. And I don't know what the flow rate's going to be, so we'll call that F1. For stream 2, it's going to contain 80% air, 20% ammonia, and no water, and it's going to be 300 pound-moles per hour. And this would probably be what we would later want to identify as our basis. Stream 3 is going to contain air and ammonia. I don't know how much, so X3 for air and X3 for, I'll go with M for ammonia. But we can safely assume there's little to no water in this, okay? There may be some, but you could either put an X3 for water or you could say 0 there. I do not know the flow rate of this, so this will be F3. And for stream 4, I would assume that little to no air will be picked up, but some ammonia will be, so X4 of the ammonia and X4 of the water, because I don't know what that composition will be, nor do I know the flow rate. So the last question here is, what on earth is the deal with this statement, an absorber is to recover 99% of the ammonia? Okay? A material balance would say that so much comes in equals so much coming out, okay, if it's steady state. This doesn't quite fit into that, so it's not a material balance. Sum of xi equal to 1, well, that would mean that it was talking about the compositions within a stream, how they add up. And it's not really saying that either. A process spec is anything else that I haven't used somewhere else that describes what's happening in the problem but isn't a material balance or a sum of x equals to 1. So this statement fits into that last category there.